Hi, welcome back to my math videos. Today I'm going to show you a new topic in this channel, partial differential equations. I've made differential equations in the past, but this is a new topic, and let's get started. So we have the partial the partial derivative, the second partial derivative of u, which is a function of x and y, of x 2 times, and then minus the original function is equal to 0. So if you just look at it as a normal differential equation, this is a kind of a fairly simple differential equation. I'm going to turn this into just a normal differential equation and try to solve it that way, and then kind of rearrange the variables. So let's say this is u double prime, the derivative of u 2 times minus 1 is equal to 0. This is a fairly simple equation because this can turn into a quadratic equation of u squared minus 1 equal to 0. And so the solutions here are u is equal to plus minus 1. So as a result, we can write the solution as u is equal to a, which is a kind of constant, times e to the negative x because of the negative 1, and then plus b times e to the positive x because of 1. But in this case, the a and b are constants in normal differential equation. But when we do it partial derivatives, the function of u is in terms of x and y. So technically, these constants of a and b become a function of y because we're technically dealing with functions of two variables. So our final general solution in this case becomes u is equal to, and I'm going to call the function of y as g of y, which is a function of y, times e to the negative x, and then plus, and then we have a different function of y, we can say h of y, times e to the x. And so you can use the scale of partial derivative to take the derivative of this. And since the y we treat it as a constant, this becomes gy times negative gy times e to the x. And then if you do all of these, you definitely end up with 0. So this is a way of kind of a simple partial differential equation of kind of turning into normal ODE and DE, ordinary differential equation, and then solving it that way and then plugging back in the function of y. I hope you enjoyed this video, and goodbye.